Hello everyone, in this video I will go over the solutions to the study guide for test number 3 for business calculus. Question number 1, they give you this function that depends on two variables, x and y, and they ask you to find the second derivatives, partial derivatives. So let's start with the derivative of f with respect to x. Remember that if you are taking it with respect to x, that means that y is considered a constant. So you have y in here and y in here. So therefore, the first derivative will be 2x times y to the 4, because y is a constant. The derivative of e to the x is e to the x times ln y, because it's a constant. And then the derivative of 7x is 7. All right, so then the second derivative is the derivative of the first derivative. So in this case, you have x in here again, but notice that there is no x here. So this is a constant, and y to the 4 is a constant. So the second derivative of 2x is just 2, so this will be 2 times y to the 4. The derivative e to the x is still e to the x. ln y is just a constant, and the derivative of 7 is 0. Okay. All right, now, if we do the derivative with respect to y, now x is the one that is considered a constant, and this is the variable. So then this will be x squared, which is a constant, times 4y cubed, which is the derivative of y. This is not implicit differentiation, so you don't have to multiply by y prime. The derivative of ln y is 1 over y. Remember that e to the x in this case is a constant, so it will be e to the x times 1 over y. And then the derivative of 7x is 0, because it's the derivative with respect to y, now with x. All right, now if we find the second derivative, remember that that's the derivative of the first derivative, and we're doing with respect to y. So this is a constant, so therefore this will be 4x squared, that's the constant you have. The derivative of y cubed will be 3y squared. Then e to the x is a constant. The derivative of 1 over y, remember that 1 over y is the same thing as y to the negative 1. So therefore the derivative of this is minus 1 y to the negative 2. So this will be minus 1 times y to the negative 2. And you simplify, this will be 12x squared y squared plus, because minus and minus is plus, e to the x times y to the negative 2. You can rewrite this and put this on the bottom, but this is good enough. Now the last one that we need to find is the derivative with respect to x and then to y, or with y and then x. So therefore you can either use this one, and then the derivative with respect to y, or this one and do the derivative with respect to x, and it should give you the exact same thing. So I'm going to use the f of x. So f of x, remember, is equals to this, 2x y to the 4 minus e to the x ln y plus 7. So f of xy is going to be the partial derivative of this, but with respect to y. Okay. All right, now notice that this is a constant, and this is a constant, obviously. So then this will be 2x times 4 y cubed minus e to the x times 1 over y plus 0. or this is equals to a x y cube minus e to the x times 1 over y. Now, you should check that if the derivative of this, now with respect to x, it will give you exactly this. Okay, now let's move to number 2. In this one, you need to use the substitution method to find the integral. The substitution we need here is u equals to x to the 4. Notice that the u will be 4x cubed dx. And if you look closely to this, this will be e to the u du. This is e to the x to the 4. Notice that the du contains 4x cubed, so you have x cubed here and the x, so you have this extra 4. So to fix that, you multiply by 4, and then you integrate. Remember that the integral of e to the u is just e to the u plus c, but u was equals to x to the 4. So that's it. So this is the answer. Now you can check that this is the answer by taking the derivative. It's not required, but you should try it to make sure that you convince yourselves that this is the antiderivative of this. Now for part B, if you look closely to this, notice that the derivative of this is this. So therefore, this should be your choice for u. So we're going to select u to be x cubed minus 5x plus 1. Since the derivative is 3x squared minus 5, all of this the x. So notice that this is exactly this part right here. So therefore, this is the same thing as the integral of the u over u, which is one of the 5 basic integrals I told you to memorize. So this will be the antiderivative. This is just ln of u plus c, where u is equals to x cubed minus 5x plus 1. And that's it. Don't forget the plus c. Okay, in question number 3, it's asking you to find the average value of the function, or the average shaded area. Remember that the average value is equals to 1 over b minus a, or the integral from a to b of f of x dx. So in this case, f of x is equals to x squared, and this is going from 1 to 3. So therefore, a is 1 and b is 3. Okay. So therefore, the average value of this area is going to be 1 over 3 minus 1, the integral from 1 to 3 of x squared dx, which is 1/2 the integral of from 1 to 3 of x squared dx. If we integrate this, you have 1/2 already times 1/3 x cubed, and x goes from 1 to 3. So therefore, this is 1/6 times 3 cubed minus 1 cubed, which will be 1/6 times 27 minus 1, or 26 over 6, and whatever that is. And number 4 is asking you to evaluate the integrals. So first we find the antiderivative. The antiderivative of x squared, or the square of x. Remember that this is the same thing as x to the 1/2. So the antiderivative is the same thing as x to the 1/2 plus 1, or 1/2 plus 1, which is x to the 3/2 times 2/3. And then the integral of 1 over x, we talked about that many times, is just ln x. And in this case, x goes from 1 to 4. So we plug the limits of integration. This will be 4 to the 3 halves times 2 thirds minus ln of 4, and then minus the lower limit, which will be 1 to the 3 halves times 2 thirds minus ln of 1. Remember that ln of 1 is 0, and 1 to any power is just 1. All right, then 4 to the 3 halves, so you use a calculator. This is the same thing as 4 to the 1 half. Q, which is 2q, which is just 8, or you can use the calculator. So this will be 8 times 2 thirds minus ln 4, and then minus 2 thirds. And then you can just use a calculator and complete that. 1b is an improper integral because this limit goes to infinity. The process is identical. You just had to, when you plug in the limits, is technically you are taking a limit. Okay? So therefore, this is the same thing as the limit as b goes to infinity of the integral from 1 to b of e to the minus x dx. Now recall the integral of e to the minus x dx, if we use the substitution e to the minus x du will be minus dx. So this is just minus e to the u du, which is just minus e to the minus x. Okay. Therefore, this is the same thing as the limit as b goes to infinity of minus e to the minus x from 1 to b, or the limit as b goes to infinity of minus e to the minus b minus e to the minus 1. Okay, so the minus goes outside. And we talked about this before. Remember that this limit, which is essentially, you don't want to write the limit, is technically wrong, but you essentially just plug in the infinity in here. So you plug in infinity. Remember we talked about this, the e to the minus infinity approaches to 0. You can see that from the graph. This is the graph, it goes to 0. So this will be 0 minus e to the minus 1. So this is just equals to 1 over e. And number 5 is asking you to use integration by parts to solve the problem. We're going to pick u to be ln x and dv to be xq. So that means that the u is the x over x, and b will be 1/4 x to the 4. Remember, the integration by parts is equals to ub minus b du. So therefore, this will be ub, which will be 1/4 x to the 4 ln x, minus b, which is this, du, which is the x over x. Notice that this, all of this simplifies to 1/4 xq dx. You simplify. So therefore, this is equals to 1/4 x to the 4 ln x minus 1/4 the integral of xq dx. But we just did this integral right now, right here. The integral of this is this. So we have 1/4 already. We're gonna get 1/4 again, x to the 4 plus c. So if you simplify the whole thing, we're gonna have 1/4 x to the 4 ln x minus 1/16 x to the 4 plus c. That's the integral. All right, in part B, you also need to do integration by parts. So we're gonna pick u to be x and dv to be e to the 2x. So therefore du is going to be just the x, and b is going to be 1/2 e to the 2x. You use substitution, or the derivative of this is e to the 2x times 2, so the 1/2 will cancel the 2. Again, the formula for integration by parts is the following. So we apply it in here. This will be x times 1/2 e to the 2x minus b du, which is just the x. You will simplify. This is 1/2 x e to the 2x. And then you take the 1/2 again, and you integrate this part, which is identical to this one. You're gonna get obviously the same thing. So this will be 1/2 e to the 2x minus 1/2, and this integral is again 1/2 e to the 2x plus c. So you simplify, this is 1/2 x e to the 2x minus 1/4 e to the 2x plus c. And that's it. Now, question 6 and question 7, they were done in test review 2. So just check the video. The same thing is for number 7.